Now, let's have a look at logarithmic differentiation. What do I mean by logarithmic differentiation? This is another approach of differentiating a given function, which is a product or quotient of two or more functions. Meaning that logarithmic differentiation can be used to take care of what we use product rule for and what we use quotient rule for. Now, how do we go about it? Let's go and solve these two questions to throw more light. Number one, let y equals the given expression x plus 1, x plus 2, x minus 1. It is obvious here that we have product of three expressions here. 1, 2, 3. These are three functions multiplied together. So what do? We take the log of both sides. That means log y equals to log into bracket x plus 1, x plus 2, x minus 1. According to the law of logarithm, each of these functions will take its own log and will be separated by addition sign. So we have log y equals log x plus 1 plus log x plus 2 plus log x minus 1. I apply law of logarithm. Alright, what do? We differentiate each of them. Alright, let's go there. When you are differentiating log, it will give you 1 over whatever you have in front of it. That is y. But do not forget that y is a function of x. So it has to go with dy dx. When you when you differentiate log, that will give you 1 over whatever you have here, that is what? X plus 1, multiply by differentiating what is inside the bracket. That's the way to go about it. So when you differentiate what you have inside bracket, it will give you 1. So that means it will result to the same thing. Plus 1 over, that means 1 over x plus 2. When the times, you are supposed to differentiate x plus 2 also, but that will give us 1. So the result will not change. So the same thing applies there. That's 1 over x minus 1. Now, having done this, the next thing now is to use this y to cross to the other side to multiply the whole of this. So your dy dx will now be y into bracket 1 over x plus 1 plus 1 over x plus 2 plus 1 over x minus 1. Then you replace y with whatever it is representing. And that means the whole of this will be used to replace y, because y equals to the whole of this. So we now have dy dx equals to x plus 1, x plus 2 in bracket, x minus 1, then open bracket, the whole of this. 1 over x plus 1 plus 1 over x plus 2 plus 1 over x minus 1. This is our result. If you want to simplify further, just use this outside to multiply each of the terms inside. That's all. You can see that is faster than even product rule. And don't forget, these are three functions. So, though you can still use product rule for three functions if you want anyway. Even more than three functions. Alright, that is taken care of. Let's go for the second question. That's number 2 question. Let y equals x raised to power sine x over tan x. What do you do? All right, take the log of both sides. That will be log y equals log x raised to power sine x over tan x. Do not forget that when you have division and you want to separate the functions, the quotient, the division will become minus according to the law of logarithms. So we have log y equals log x raised to power sine x minus log tan what? X. Now, we are supposed to differentiate now, but according to law of logarithm again, sine x can be shifted to the front of the log here. That means I have log y equals sine x log x minus log tan x. I think that is clear enough. All I have applied so far is law of logarithm. I have not differentiated. Now, about time to differentiate. When you are differentiating log y, that will give you 1 over y dy dx, because y is a function of x. When you are now differentiating sine x log x, you apply what? Product rule. Let this be your u, and this your what? V, or whichever one. So I have u, which is sine x, times dv dx will be 1 over x, plus v, which is log x, times du dx, which is what? Cos x. So this is the result of this. Then minus, I now want to differentiate log tan x. You differentiate log, that will give you 1 over whatever you have there, which is tan what? X. Times, you now differentiate tan x, that will give you sec square x. So, what next? Okay, y will be brought to this side to multiply. So the y dx will now be y into bracket, this will be sine x over x plus log x cos x minus sec square x over tan x. Finally, we replace y with whatever it is representing, which is this. So that means dy dx will now be x raised to power sine x over tan x into bracket, then you repeat all this. Sine x over x plus log x cos x minus, do not forget that sec square x is 1 over cos square x. So, and tan x is 1 over tan x is a cos x over sine x. So definitely cos x, we cancel cos x here. So we have 1 over cos x sine x. That is if I don't want to leave it this way. But fine, let me leave it. Sec square x over tan x. And that's all. Is that okay? Fine.